Don't forget to subscribe and put the bell icon so that the new video comes to you first. Thank you for watching.
Hello friends, today we are going to start our next basic electrical topics, Kirchhoff's voltage law. Just before this, I already uploaded one video related to Kirchhoff's current law. Now we are going to start the Kirchhoff's voltage law. Kirchhoff's voltage law is basically applicable for the loop circuit. That means if there is any circuit and there the current is rotating in any circuit, then only the Kirchhoff's voltage law is applicable. So just I'm going to make one circuit, very simple. I put one resistance R1, then one battery, we say E1, then again another resistance R2, then again another battery E2, and then again here we put a resistance, and here we put a battery but the opposite direction. That means E1, E2 and the E3. Why we say this E3 that is in an opposite direction? Because if you check, if you consider this E1 is your reference, E1 is your reference, so this is the plus and minus, and the current should go from plus to the minus. So we say the current is I. Now you check for this circuit, plus to minus is going as per this loop. Here is also minus plus, so plus to minus also going, but here if you check, the current is entering to the plus. The current is entering to the plus for this E3 battery, but the current is leaving from the minus. So that means so E3 is the opposite direction. So for as per the Kirchhoff's voltage law, it will be the total energy, the total EMF, electromagnetic force, that is equal to the total losses. Losses means here losses is the current that pass through the resistance. So there is a voltage drop here. So total EMF equal to the total losses, or you can say the total voltage drop across all resistance. So the equation it will be, we say E1, that is our reference, so write it down, E1 plus E2, because both are the same in the same direction, but E3 in the opposite direction. So right here minus E3. So that is the total EMF, and the total here the voltage drop across the resistance. The current is same for this one single loop. For this loop current is same. So and the resistance here R1 plus R2 plus R3. So as per this law, we can say the summation of EMF in any loop circuit, that is equal to the total IR, that means the voltage drop across the resistance. So you can make it the summation of, if we put here I, so I equal to 1 to N, that is equal to I equal to 1 to maybe K, that depends on the circuit. So now we can say the equation is comes like I equal to 1 to N EI minus I into I equal to 1 to K Ri, that is equal to 0. So that is called the Kirchhoff's voltage law. Just go for a small problem, a very small problem, then you can understand what's the situation for the Kirchhoff's law. Here we are going for a small problem. Let it be first we make a voltage 5 volt. There is a 2 ohm resistance. Then we make a opposite voltage 3 volt. Then there is a 5 ohm resistance. Just make it complete. For this circuit, we consider 5 volt. This is our reference, and our current is passing from this circuit, that side. This is I. So now, if you check this 5 volt, from plus to minus the current is coming, but for the 3 volt, the current is entering to the plus. So that's why it will be 5 volt minus 3 volt in this total EMF. That is equal to I into 2 ohm resistance, then again I into 5, this 5 ohm resistance. So what will be our answer? The answer is the 2 volt, and here 5 plus 2, 7 into I. So from this part we will calculate the I equal to 2 divided by 7 ampere. So this is the basic of the Kirchhoff's voltage law. Now we are planning to make one loop circuit and how to solve the loop circuit with the help of Kirchhoff's voltage law. Let's check. I'm going to go for the loop circuit. One problem, I will put here 5 volt, here 2 ohm resistance, here 3 ohm resistance, here is also I put 3 ohm resistance, and here there is another voltage. I keep here suppose it's a 3 volt. Now check how to solve this equation. So with the help of KVL, first we have to check a loop. First we make a loop. So in this loop, one current is I1, and another also make this loop I2. So this one your loop 1, that is your loop 2. So for loop 1, the equation, it will be 5 volt, because the current is going from the plus to minus 5 volt, that is equal to one current is rotating 2 into I1, plus here you check one current is going this side, another current is going that side. So I1 minus I2, what is the voltage? Resistance, sorry, 3 ohm. So now your equation is 5 volt equal to 2I1 plus 3, 5I1 minus 3 I2. This is one equation. Now comes to the loop 2. In the loop 2 you can check the current is entering plus, so automatically it will be minus 3 volt, and the current is here the resistance 3 into I2. Here this is a very important things, because the current is going, we can consider I2 is a positive here, but here for the 3 ohm resistance, one current is going this side, another current is going this side. So I2 minus I1 into how much? 3. So now 3 volt equal to 3 into I2, sorry, 3 I2, yes, 3 I2 plus 3, that means the 6 I2. 6 I2 minus 3 I1. This is the second equation. This is the second equation. So how to solve this equation, these two equations? So just to get the value of I1 and I2, just what I will do, I just multiply this one 3 with this, and 5 with this, sorry, 5 with this equation. So what we will get for the first equation, 15 volt, 15 I1, 9 I2. For the second equation, 15 volt, 3 30I2 minus 15I1. If we add this one, this cut, this cut, so we'll get 0 equal to 0 equal to here I2, that means whatever may be the I2, 21 I2, so I2 goes to 0. So how much I1? We put 0 in the equation number 1. 5 volt equal to 5 I1 minus 3 I2. 5 volt equal to 5 I1 minus 0. So I1 equal to 1 ampere. Just a division. So here we will get only one current. There is no other current here as per this loop equation. So this is the basics of the fundamentals, how to make the loop equation. Why we are not getting any current. This is also I can show you here. If you apply the voltage divider law, you can find if 1 ampere is flowing here, then here the voltage is 2 volt, and here these 2 points the voltage is 3 volt. If 3 volt is here and if this circuit is 3 volt, then there will be no current. So this is the norm. So though we can later we can know how the circuit, this is the tricks of the circuit. So here I don't know, unknowingly I put the equation, but unknowingly we get this one. This is the loop circuit. If you like this channel, you just subscribe this channels and spread your friends, so that's this channels, this is your channels, and it will be grow fast. And basically we used to take only this electrical and electronics related all the problems and the basic projects with this channel. So hope you are enjoying watching. Please share these channels and subscribe these channels so that it will be grow. Thank you.
Don't forget to subscribe and put the bell icon so that the new video comes to you first. Thank you for watching.